everyone. My name is Rémi Duquette. I'm the Vice President of Maya HTT on the Industrial AI side, and it's my pleasure to welcome you to our webinar today with Ashish Chaudhary and myself, where we will cover cost-effective deployments of smarter fleet monitoring. And hopefully you see a lot of value in what we discussed today and some of the specific example. And now that I've introduced myself, maybe we can go ahead, Ashish, and introduce yourself.
Hi, everybody. Let me also welcome you on board for this webinar. And it's a great pleasure to be on the panel to discuss with Rémi the cost-effective ways of monitoring fleet. And it gives me a lot of pleasure to be on this panel to discuss as a first webinar with Maya HTT. Icons is bringing to the maritime industry clients. And just a little bit about Icons. Icons and Company is a consulting company based in Monaco, and we have multiple pillars, 4 pillars that we serve, provide our offers. And within our digital pillar, we are focusing on maritime clients for their digital transformation and AI adoption. This is where Maya HTT is collaborating, has agreed to collaborate with Icons, and I am really excited to start this journey with this webinar. And now I hand over the floor to Rémi for the presentation, and I stand in for wherever is needed. Okay, so let's start, Rémi.
Excellent, thank you, Ashish. And yes, so the collaboration, as in any let's say project on the fleet management side, it takes an ecosystem to bring the value. And so it's a pleasure to collaborate with Icons company, and I think we together joining forces makes a lot of sense for you that are listening. Lots of people today, so hopefully you stay the course with us and ask some questions towards the end for clarification of anything that was not clear during the presentation. So maybe just one slide on the Maya HTT side here. More than 195 successful industrial AI projects, a lot in the marine space, and I'll explain and showcase a few of those on the fleet management, whether it's for energy efficiency, predictive maintenance, regulatory challenges, or safety and security. So for key topics typically that are top of mind for fleet operators. And 40 years in business. We have a nice footprint in France as well. Not in Monaco yet, but with Ashish and Icons company, we now have a collaborator there, so it's awesome. And it's my pleasure to go ahead today. As in any endeavors, when we look at fleet management or any other business needs for fine-tuning your operations, it's important to always start with an approach where you look at your business case first, and then you look at how the technology can be deployed. Today, we'll showcase some examples where it was deployed very cost effectively on the fleet management side, but where you gain all the results that you were expecting for. And it's important to start from that result, right? Think of it as in 16 months or 18 months from now, what would you announce to your board on the at your company, and then walk your way back from there, right? Peel back the onion. And so that announcement to your board becomes your goal, and then you see how you achieve it, instrumenting, digitalizing your fleet and adding sensors if needed, and then moving to advanced analytics, understanding better what's happening, and then applying industrial AI and in the marine space. And I'll show you some very specific practical examples there. So from that ability, from a Maya standpoint, we've deployed these solutions, these industrial AI solutions on top of more than 6.7 million real-time telemetry points Telemetry points can be, again, some, power, temperature, current, all sorts of telemetry that we can gather with you as part of the fleet management and monitoring system. And it can also extend to other types of, audio or video or other types of sensors that you can leverage as well in combination for a specific use case. So all of this, really, our ability is to also work with multiple third parties and to deliver value back to you. On the fleet operations and service side, there's really four kind of areas where we can help you. First, on the consulting side with Icons, where we collaborate to establish the best architecture for you, understand, again, your business goals, and align the technology stacks that you want to deploy to achieve those business goals. And then we have a very significant and talented team. And when we combine both Icons and Maya HTT, hundreds of people that can deploy on the data engineering side, the dashboarding side, the AI components. We have various teams that will collaborate to deploy the solution for you. And the typical use cases are around asset condition monitoring, increased performance, monitoring utilities, and others. So this is really what we're going to talk about today, and the journey of others. From a tech stack perspective, of course, Maya HTT has been an integrator of Aviva Pi and other systems on the Aviva side, on the Siemens side, Insights Hub, on the Azure cloud, multiple components and modules. And for vision systems, anything related to NVIDIA, it's kind of something you can't avoid these days. So those are kind of four platforms and components we have a lot of expertise with. Now, today you're here because you want to see some, practical examples on what we've deployed, how we've deployed it, and the journey, right? And the cost-effective journey to get there in the most economical way, while getting the return on investment, as fast as possible. So one of the example and I will present a few slides here that were co-presented between Maya HTT and the CSL group. Once at Pi World in 2019, and then again at Aviva World in 2023. And you'll see the evolution of some of the slides, right? This was on the earlier side of the CSL journey. You can see it started in 2017 with a pilot on 2 ships. And that allows, us to align on the templates, the architecture, understand what is needed for a cost-effective deployment. Before you scale up to 500 vessels, right, you need to understand really your environment, your ecosystem. And just starting with 2 or 3 is perfect. It gives you, a small footprint where you can see the value and test out various configurations for the rest of the fleet. Then we did in 2019, 2 years later, we've expanded based on the success of the pilot. We expanded to the 17 first vessels. These were the most critical, the most used vessels. So again, you go into, peel the onion and target the vessels that are of most interest or where you have most problems with, right, from a business standpoint, so you can get a higher return on your investment earlier. And then, of course, COVID hit on 2020, and it allowed us actually from remote to deploy to a very large set of vessels. So we increased to the 35 plus vessels at that point, and then 50 vessel plus today that are, fully monitored and and deployed worldwide. They have actually literally worldwide fleets. So it's the vessels that go around the planet. They have a Canadian fleet, American fleet, Australian fleet, and European fleet. So they really are all around. And of recent, they are moving to Africa as well. So it's really all over the world. From a gains and efficiency, and I'll show you some more details in here, but as a summary slide, they move dry bulk cargo. So under the hood, if you will, you have salt and other powdery components that are being moved around. And they have a huge system of conveyor belts that move back the cargo. It's called a self-unloader. So they don't need anything at shore to unload. They unload themselves, using all the equipment on the vessels and under the belly of the vessel, truly. And you see the boom on top that can swivel around and just drop the dry good on shore. So that's their value add. you know, it's that kind of a vessel that are moving around. In terms of the energy efficiency, one of the key elements of the ROI was built around the energy efficiency, and the other one was built around the smart anomaly indicators. So avoid issues that could cause you problems or unplanned downtime of equipment, or worst case, you know, tragic incidents. So when we look at the benefits overall for them over the years, you know, 10% of the ROI was related to the compliance and the process, you know, to become more efficient. We often forget the non-quality and the non-efficiency components that are built in an organization, and by making things visual and understanding how things operate, we often find, you know, very interesting use case that all of a sudden, you know, increase the ROI. So 10% of benefits around that kind of area of compliance and process digitalization. And then on the bigger side, energy management, 50% of benefit, and 40% on anything related to asset health management, whether it's engine, auxiliary engine, the pumps, the conveyor belts, all their equipment that are on board. In terms of failure avoidance, that's a key one on the right-hand side. You see here, you know, 133 failure were avoided in 1 year alone. So that was in the early days of testing out predictive maintenance and AI-based components on top of the real-time telemetry that was gathered. So, you know, from all of this, you can see real value. From a CSL fleet deployment, again, in a very cost-effective manner, we took templates, and from the PI system in this case, they're using the Aviva PI system for their monitoring. We componentize all the systems, and then we use templates for each of the systems. So you have the engine, you have other components, all of these gather data. The important cost-effective way of doing it, whether you use Aviva PI or other tech stack, we need to sit down with you and leverage those templates, right, to make sure that they are deployed at scale and easily deployed across multiple ships. If you're lucky, you have ships that are very similar class or very similar type with same equipment if if you're very lucky. And in those cases, we can even fast track even more. In the case of CSLs, there were still a lot of differences between the different fleets and the different vessel types and classes. So we had to modify, but anything that was common, we put in a class of its own so that we can deploy it very quickly. So you can see here all the little systems, each block, green block that you see that are deployed monitoring blocks of information and data attributes were deployed on these systems. So multiple systems per ship, and each block is one vessel, as you can see there. Collect the information locally, buffer it, right? Sometimes you have SATCOM, sometimes you don't, sometimes you have port, you have LTE, so you have various communication throughput, and so it's important to have asynchronous communication between each of the vessel and your central repository. The reason you centralize the data is because then you can build, you know, more efficient AI models and then retrain them at the central location and then redeploy it across the fleet. So this is an important architecture component of it, to centralize the data so you can use more data for the AI training, especially for predictive maintenance that comes into play. CSL, one of the area on the energy management side was I'm going to call it a simple example of basic machine learning, where you can use multiple attributes of your fleet and your vessel in operation and dictate what the optimal speed would be with those conditions, and simply tell the captain what that optimal speed is. You're not controlling the ship, right? You're not controlling the speed of the ship, the captain is, but you're recommending, right? It's kind of a recommender system. You're recommending to the captain what the optimal speed is given the current conditions, because they may not be aware of, you know, current changes or other things that are, you know, happening, or the logistics, right? There's a port, all of a sudden there's a big traffic jam. So slowing down, you know, to save energy makes a lot of sense in those cases. So all of this can be fed back through those things. And with a trial of 8 ships that we've done on these simpler machine learning components, you see, you know, with speed optimization, Without speed optimization, you waste a lot of energy. You're definitely inefficient. And you can see the difference between the two is, 300 metric ton of fuel that was saved in that for 8 ships in that 200 days sailing days. So trial. So that's a very, important component. Another way I like to show what predictive maintenance is and does to the telemetry, because people then wake up and say, oh, that's what predictive maintenance can do for us and help us with. In this case, the maintenance actually helped two things. It helped the energy consumption, the fuel consumption, as well as the component life. So the component that was at fault in this case was the turbo. So the turbo air temperature was rising abnormally, and no one had detected it because it was still within the range of let's say, quote unquote, normal operations, but it was abnormal given the surrounding conditions, the environmental conditions and other conditions. So based on that, you could see on the left-hand side, it's a 15% increase delta between the white line, which is what the engine should have been consuming in kilogram per hour, versus what it was in green consuming in kilogram per hour based on the sensors, right? So there's a 15% delta based on what, the AI say it should be consuming given the condition versus what it is consuming. So as we can go back in time and you can see how those two curves drift, against each other. But here was just a snapshot of, the current state, and you can see how inefficient it was. And then by pinpointing that it was the turbo air, there was a jam, essentially a little, a blockage in the turbo that was raising that kind of, the engine needed to work extra hard, 15% harder, to generate the same power on the shaft. So in the end, those are the important things where maintenance plays an important role. A lot of people need visuals, so I like to show this little animation on the remaining life of components, whether it's a turbo or other components on your ship. In the end, you have a threshold where you say, okay, our maintenance is based on that threshold. The life of my components will degrade over a certain period of time, and typically the first approach is a linear approach. So you see the blue baseline is typically where you say, okay, I'm going to plan my maintenance at some point. But with machine learning and data, right, we can then track not just the amount of usage, but also the impact of that usage on the remaining useful life. And that can be a basic machine learning algorithm that will calculate this. And in this case, you can see at the end, when we would have done the maintenance, there was still 40 days left in this component where we could have, extended the life without any issue, right? So this is an important kind of visual to understand what the remaining useful life forecasting can do for you from a cost perspective, right? So you reduce the cost of maintenance and not just avoid, of course, the unplanned downtimes, but also reduce the cost at the same time. So very important figure to realize. This was an interesting little nutshell of, when we talk about outlier detection and things that go awry on vessels, there are many, many different things. So in this case, on CSL, we have a little animation there. So on the 6th of that month, 3 outliers were detected. No one really took notice of that, because everything on the ship, all the indicators, the alarms, nothing went above normal. On the 7th, the next day, 9 outliers, also 3 times more outliers, show up. Then, 3 days from the first outliers, there's all of a sudden 200 outliers. Now, the crew starts paying attention. Things are going awry. So inspection is done, and it goes back to normal. Nothing is fixed though. So they think they open something, and something maybe was loose or whatnot, and they decide to continue to move on. But as they continue to move on the 10th day of that month, 11 new outliers show up. So at that point, they should have taken action. But anyway, now it's retrospective. We're looking back in the mirror. But today they would have taken action. But on the 13th of that that month, 159 new outliers, and the vessel essentially stops for a pilot station, and the CPP is stuck in the astern position, so they essentially can't move anymore. So it's stuck to safety. But you can see how early, from the 6th of the month to the 13th of that month, outlier detection and anomaly detection and predictive maintenance is all about this, is avoiding these issues. And now that CSL has categorized these, right, they believe and they rely on that information to go and take actions. But in that case, that was, quite a few years ago. Of course, they talked to safety, and that was fine. But in the end, based on that experience, they are now, operating in a much safer fashion. So another client of ours that permitted me to show one slide on the work we're doing with them is Dallas. So essentially, they are looking at after a modern Navy fleet, and they are maintaining that fleet for the Canadian government. So in their case, they are essentially operating the fleet and making sure that from a predictive maintenance and data acquisition, everything is looked at. And so Maya has been chosen to deliver some of the data analytics, the data acquisition, and also all the predictive maintenance and advanced analytics that goes around those systems. So again, different type of fleet, different type of vessels, but very similar problems as what CSL uncovered. And more recently, C-SPAN as well made an announcement in March 26th. So I have to limit myself to the announcement, official announcement on the website. But in any case, Maya has partnered with C-SPAN and CSL to build about 26 AI-based predictive maintenance models for their fleet operations, and avoid issues on the fleet that they are monitoring, on top of augmenting the CSL fleet with additional novel predictive maintenance component. So hopefully this gives you some good sense of what we can do and deliver from a monitoring and predictive maintenance and energy efficiency perspective. One of the key value that Maya HTT brings to the table is also that, to us, data is more than just data. There's a physics understanding of the data, and that's key and important for you to reach the value. I'll show some very, very brief example here on, before you go to operating the vessels, Maya has often been involved from a professional services standpoint to simulate some of the issues that we then monitor and for in operations. Here you see some of the hydrodynamic performance of vessel, propeller noise. You can see some chimney stack and the winds across the aerodynamic performance of the top deck of the ship, wind loading and so on, the gas dispersion for turbulence and emission tracking. So understanding, again, the physics behind the data helps us help you in a better way. Here you can see some aerodynamic performance again and saving costs on the wind tunnel. That's separate. That's more on the design side before you go to building the ship themselves. But you can see the types of simulation that Maya from an engineering standpoint can bring to bear. Same for cavitation, erosion, vibration. So we understand, again, the physics of the operations before it gets into operations. And with the help of Ashish and also Icons, we together, I think we cover the whole life cycle of those vessels, from design, the construction, and all the way to the operations and maintenance of those ships. Again, here, systems performance and control to understand the dynamic of what's happening inside with the engine and the multiple engines and the multiple pumps and everything else. So at the system level, we can, simulate upfront and get even synthetic data sometimes to simulate onset of failures, right? So hopefully you don't have too many failures in your operations data, but we can, from a Maya perspective, we can augment that data set, that operational data set, with synthetic data that simulate the onset of a failure or a failure type. So from that perspective, you gain intelligence on that front as well. Here's Hyundai Heavy Industries with more of the engine design, again at the high-end system level of their engine, how to optimize the engine. So not only we understand the operations data that come out of the engine, but also the system of how to control more efficiently that engine is well understood by the Maya team. Battery simulation, more and more, of course, batteries and electric components are coming on your ships and your vessels. So understanding the dynamic of this, it's tricky, as you probably know if you're in that transition. So we can help you understand those difficulties that you might have operating them. So on that note, I'm getting here to the end of the core of the presentation. I wanted to leave a lot of time with you. First, we'll do a poll in a few minutes, but before that, I would like to ask if you see in the right-hand side, there's a question panel where you can submit your question. And I will just wait a few seconds here to see if you have any questions. Ashish, I don't know if you want to add a few words while we're waiting for the first question here to come in.
Yes, I think with the combination, the capacities that Icons and Maya brings to the table, we indeed cover the whole business life cycle of maritime players. So starting from the shipbuilding as well as up to the operations. So the operations takes the large chunk of that life cycle. So where the money is made or lost, I would say. So adapting to the newest of the technology. I mean, I think the industry is under tremendous pressure to report on their carbon footprint and all. That's how the information systems are being upgraded. So I think this is a great opportunity for all the maritime players to grab the power of AI, the data, let's say, starting with the cleansing of the data, understanding what data we produce and recognizing their value, and employing rapidly, cost effectively the analytics and automating them with the help of computational power of today that we have in our hands. So yeah. I think it's a great opportunity.
Mm-hmm. And I see here first question on the, how many times do you need to run the first step from a pilot project perspective? With CSL, you saw two vessels were first instrumented on a pilot framework. Typically, we would suggest 2 or 3 vessels, depending on how big your fleet is and how different the vessels are on your fleet. So, you would typically want to pick, if you have a large fleet of, say, more than 100 vessels, you'd want to pick, one that's uncommon. That's let's say, the most different than all the others. One that's, let's say the blueprint, the one that you have more of. And then maybe one that has more difficulty with, right? So 2 or 3 typically from a pilot perspective. And again, the goal of the pilot is twofold. One is to validate the architecture and the technology stack that you're going to deploy, but it's also to understand, how many templates we will need to build so that we can scale up with you and give you a true cost of what the deployment looks like on a per vessel basis based on different classes that you have. So really choosing that good mix of class differences and systems that are different across your fleet is what we really want to validate with you. In the end, we see this as a partnership. it. CSL calls us, once in a while as well. To understand what is happening, and so to us, it's a collaboration, it's a partnership, and 2 or 3 vessels is probably the minimum. And then before you go to big scale up, right? You saw we went to 8 vessels on specific items, and then 17 vessels. Those numbers are actually important. Before you go to 500, let's say, you would want to go from 2 to 8 to 17. Once you're at 17, you've covered 99% of the problems that you're going to encounter. Okay, but until then, you will still see some, episodic ad hoc things that we have not considered together, just because some of the things will, happen in real life that we can't predict, both on your side and on our side. But the important thing is we've done it so many times now on very large fleets that we can help you get it done faster on the one hand, because we've done it multiple times, so we know where the gotchas and the dead bodies are in the closets. Halloween is coming, so I'll make a little comment there. But anyway, that's probably how many vessels you want to plan for. Yeah, so that's the first question. And AI training, how many failures do you need? So that's an important question. So from a predictive maintenance perspective, on the failure rates, what's important today with the new algorithms that we have access to is not necessarily the amount of failures, because of course, hopefully, fortunately for you, you do not have many failures. So that's important to recognize, that the number of failures is low level of data, which is fine. We have now ways to essentially learn from the normalcy of your system, right? And as things progress, we will flag outliers, things that are going outside the norm of the operation. We will flag them, and then those will be classified in the aftermath. Okay, this was because the filter, the oil filter was clogged. Okay, so that class will be done in the aftermath. And then the next time this same problem happened, now instead of saying, something is going wrong, it's going to say the oil filter is clogged, right? So what's important is really we learn from the normal operations data that you have. We, of course, eliminate the outliers that may already be in your data. There will be some, I guarantee you. And essentially over the course of a 3-month period, maybe, or depending on the number of vessels, you will then classify all of those very easily and smoothly over time. But at least you're going to catch all the outliers, right? All the things that could lead to a big problem, you will catch them, because we will learn from a predictive maintenance, each of the system will learn from the normalcy of the data. Also, from a Maya HTT perspective, because we've done it on multiple vessels and multiple systems, we have baseline models. Think of it as pre-trained models that will need fine-tuning on your specific operations and specific data. But by and large, we have most of, if not all of the components, the base pre-trained models to deploy. So from a cost-effective perspective, rebuilding AI models take time and take effort. From our side, from a Maya HTT viewpoint, we have pre-trained models that we can leverage in some instances for your vessel fleet. So from a fleet management, applying AI components, especially on the predictive maintenance and energy efficiency side, we definitely can help with some specific pre-trained model there. Perfect. Let's see if there's any other questions. Those are the 2 at the moment. Don't be shy. While we're waiting for other questions, I will just initiate a quick poll. So just to see what's top priority for your organization. You'll see, what's the top priority for your organization in terms of fleet management. If you can click on which of those, it can be all of the above or a few of the above, but which ones you see as most important for your organization. I see a lot of, energy efficiency, reliability, predictive maintenance, supply chain optimization. Yeah. So, oh, it's very interesting. The results are coming in now. I will, and at the end, we will share later the results of the poll. But just in a nutshell, yeah, many of you see energy efficiency as the top #1 priority. On the second level, you'd have vessel reliability, predictive maintenance, and voyage supply chain optimization that are very close. And then the last two, regulatory compliance and safety and security, are the last two together, roughly the same, 17-ish%, more or less. So yeah, very similar to other polls we have run. There's many people, so it's fun to see the various percentage, and we'll share those results with you by email. Let me close this here. Excellent. Let me see in the meantime if there are no other question. And if there are no other questions, then I will just run a last poll to see if you would like to further explore some of the topics that we started to touch on today. If there's any specific ways you'd like to be contacted, either a discovery call, additional collateral from what we've shared today, or training on an audit of some of your fleet, what you have today in terms of exploration, and then we can follow up. I'll leave you another minute to answer. And by the way, if you prefer a French version, of course, we speak French as well. Ashish is in Monaco, and we have our French office. So Jérôme and myself, Rémi Duquette is a French name. So my mother tongue is definitely French, so we can definitely have a second conversation in French if needed. Perfect. Seems that the polls are stabilizing right now, so I'll give it maybe a few more seconds. Excellent. So on that note, Ashish, I don't know if you have closing remarks for our attendees.
Yeah, I think it has been, I think my observation has been like, maritime has been one of the legacy industry, and but I think there is the challenge to them, and also the opportunity, I would say, because of their size. They tend to be very slow in terms of their openness to changes. But here, I think the opportunity and the let's say it's the situation is really conducive for making a impact on their business as well as on the environment. For me, coming from an oil and gas perspective, I have seen an offshore oil and gas perspective where I have dealt ship-shaped platforms, and those are much more complex than seafaring vessels. So I have seen the real gain happening per unit. Unit means the production units. So here, with the experience of Maya, I think it's not the value can be delivered really quickly, because it's not the first time. It's not going to be an experiment, because with the experience that Maya has obtained with so many projects with maritime clients, I think the opportunity is tremendous to create value for maritime clients who are based in Monaco or around Monaco. So I really look forward to having a conversation after this, and so I would like to just end my. I mean, that's the only point I would like to add, and I let Remy to close the webinar with. Yeah.
Super. Excellent. Well, thank you, Ashish. And yeah, indeed, with the vast experience that between our two companies we have, and also the talent, the large size team that can deploy at scale the fleet management. That's another aspect that, you know, from a CSL viewpoint and others, they've really enjoyed the and appreciated the scale that we can bring also. It's not just cost effective, it's also fast in terms of what we can do, and we can, you know, in an agile fashion realign when things happen or when things don't come in as they're supposed to. We can adapt very quickly, and so from that perspective, I will close the comments in saying, you know, I hope you see the value that Maya HTT can bring with icons to your fleet monitoring, and you know, leverage AI components for predictive maintenance and energy efficiency specifically, and maybe some safety security. You still need the fleet to be safe and secure when they operate on board. So in any case, don't hesitate to contact us. We will reach out for sure with additional information over the coming days. But again, if you have a pressing need for a cost-effective fleet management monitoring solution and AI components that are pre-trained, that won't take very long to deploy, please don't hesitate to reach out to us. So thank you very much, and hope to talk to you soon. And hopefully I see you in Monaco, Ashish, next time I'm around in France.
That's the plan. We need to work on that, and let's look forward to that. Thank you, everybody.
Thank you, everybody.